Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, my name is the teacher Jean-Marie. Welcome again. Today you have a physics with the senior 5 classes. And as you remember, we were discussing on the unit number 5, and we are still discussing on this unit. So the unit is about the complex electrical circuit. It is unit number 5. And what we have been discussing with the last time, we were discussing with the potentiometer. I hope you remember that. You remember the potentiometer that we have used it into the experiment, and we even explained this potentiometer and the use of that potentiometer. So let's try to see again that potentiometer very quickly. So here we have an example of that. So this is what we call linear potentiometer. So and as you see, and as you see here, so we have the change of the length of this linear, of the displacement, makes the change of the resistance of this wire we have inside. Because as I've told you, so it is designed in a way that we have a wire inside. And this wire, when you change, because with the help of this wiper, there is a change of the displacement, the length of the wire, which makes the change of the resistance. So, and then we have this rotary potentiometer. These are two potentiometers that I can now show you right now, but I hope you still remember what we have discussed on. Now we have linear potentiometer, as I've said, and the rotary potentiometer. So then let's see this potentiometer. So it works on the principle of changing the resistance of the wire with its length. I hope you remember that. So, and it converts the rotary or linear displacement to voltage. This is another point that we have, or that we are having right now. But for this one, we have said that it works on the principle of change of resistance of the wire with its length. So I think that we have now to make a very simple demonstration with the material that I have in front of you. So because the point that we have on the previous lesson, we have simple circuit potentiometer. So that is a point that we have discussed the last time. And there we should determine the approximate value of E of electromotive force, but electromotive force of this cell that we have down here. But again, as what I have said there, we said that it works on the principle of changing this length and the changing the resistance of the, when you change the length of the wire, and there is a change of the resistance. So we are going now to do a kind of demonstration, and then after we do the example that related to what we have discussed into the previous lesson. So let's have these materials here. So as you remember, if you are saying that we have linear potentiometer and a simple potentiometer that we can now show that we can use is this one. So as you see, I've used this voltmeter. So this voltmeter, it is going to measure the potential difference across the terminals. So here we'll be having, I'll be having just a terminal. Here it is from here up to this point. Or it will now be up to this point. Or you have to here up to that, and then to here up to this other point. So I have the source of the current. This is the potential difference that I have. So let's now do this with the help of this switch that I have, and in between this in between this battery or the source of the current, potential difference, and then I have to connect it on the terminals of the battery, and then after I have the switch as usual. Then, with the help of this wiper, so normally we would have now to consider a wiper, because into the first slide we showed this linear potentiometer. So linear potentiometer, it has this slide, but that rotary also potentiometer, it has a wiper, but that wiper or a slider or what you can use to move, to change the length of this, of the wire that you have inside the instrument, inside the device that we have shown there. But now it works on the same principle as this one. So if I have this, maybe let's say that I have a length of, this is the length of this 60 centimeters. This is the 60 centimeters that I have, okay? There we have 60 centimeters. And when I close the switch, so I think you see the change. You see there is a deflection of the needle that you have into this voltmeter. And this deflection indicates the voltage that I have. So today we are going now to see that there is a different deflection of this needle when there is a change of the length of the wire, of this wire on the potentiometer, right? So if I change this distance, you see, let's have it up to 30 centimeters. This is 30 centimeters here. Do you see here it is 30 centimeters? Then I have a different deflection. So I want you now to focus on the subdivisions that we are having. Remember, we are using this 3, try now to see where we have this low range. So the low range here, and then you see it is from 0 up to 3. So then you try to see that, and it has deflected just more. But when I have this, you see, the deflection is now changing at a small value. Do you see that change? Very small deflection. What does it mean? It means that there is an increase of this length that we have here, which makes an increase of the resistance of the wire, and then there is a drop of the potential difference. And this one makes us, again, to recall on what we have discussed, saying that this is the potential drop. So it means that this potential drop is what we have as the, it is the potential, it is the voltage change as the length of the wire changes. So it means that, so this what we have said as the potential difference is approximately is proportional to the length of the wire that we have. And the constant of proportionality here is what we have called K, and this is A. L here means that if we want to find this K, then we find it to be over L. Do you get that? So it means that when you have this, when you understand this, proportionality that is between the potential and the length, the change of length with the change of potential difference, and then you understand the working principle of what we are saying here as the potentiometer. But now here we have this K is called the potential potential gradient. Why gradient? Potential gradient. Why gradient? Here, remember, we are saying on the previous lesson, as I'm saying there now. So here it means that this potential drop, what we give, if there is a change of the voltage and the change of length, what you can find is this line, this graph, and then when you find the change of voltage to the change of L, this gives you that K we are saying now to be the potential gradient. Do you understand? So I hope this is now clear. Now, as we move, let's do the example, the quick example from what we have discussed within the last lesson. Here we have an activity. So remember, this is what I came now to say, okay? So we end up having this expression. So a potentiometer wire is 8 meters long and a potential difference of 10 volts is maintained between its ends. Find the potential drop of the wire. Also, find the electromotive force of the cell, which balances against a length of 280 centimeters of the wire. So because there we have 80 meters, so my potentiometer here, it doesn't have this 80 meters, okay? It has only 1 meter, which means that maybe if I was going to show you this data into the demonstration, I would have now to bring other more potentiometers like these ones, other more 7, and then we have 8. This is 80 meters. Do you understand that? So, but now we can apply, of course, the example. As you see there, we have the given that, what do we have? We have a V there. So this V equals to, potential difference is equal to 10 volts, and we have L. So this L equals to 8 meters. Try now to see. So this is now to mean that you have all of this length there. It is going out to be that 8, but remember, this is not 8, but it is the whole length. And then what you measure is that 10 volts. But if there is another change of length L1, which is equal to 208 centimeters, this gives 2.08 meters, then find E. So this E, that balances, of course, that balances against the length of that one, of what we have. So now what is being asked here is now to find the K. Did you find that is K which is being asked? The potential drop. Try now to see there. The line number 3 into the activity. So then here you have, this is equals to V, K here equals to V over L, and this is, this V equals to 10 over 8, and this is V over meter. The unit, then K will be equal to, so can you use the calculator and then find the answer? So together with me, hurry up. And this is going out to be equal to 1.25. This is V over meter. So, and then number 2, this is A. So let's say that is A, then B. B is also find the electromotive force. Electromotive force which is balances that one. So this electromotive force E equals to, as you see, we would have now to think about this formula, the whole of this formula. Do you understand? And then you have a V over L0. This is what we have applied. And then times L that we are being given. So here we have that K, so as what you see, times L that is being L1. So this is L1. And then, so then here we calculate E, which is going to be equal to 1.25 V per this one times L equals to 2.08 meters. And then this E here will be equal to, so let's calculate that. So this is times, that is times 2.08. What did you find? So me, I've calculated 2.6 now 0 volts. Is it the same as what you have calculated? Good. So it means that yeah, correct. Now let's move on to the to what we have now to see. That is the answer, of course. Don't mind about it, but we have solved the answer there. Okay. So let's move on to this other next point. So now in today's point, I want you to it is to compare the electromotive forces. So by the end of this lesson, you should be able to perform an experiment using a simple potentiometer circuit. I think it is in the same way as what I have used there. So then need to compare the electromotive force. Check this into the page of Senior 5, and you find just on page 118, 119, and 123. There you find the exercises. So as we move on to the circuit diagram, let's see the circuit diagram here. So this circuit diagram, a potentiometer may sometimes be used to compare electromotive force of a cell with that of a standard cell. Consider the circuit of the figure on the right side. So this is the figure. So from the figure, what do we have? From the figure, as what we see, we take this, do you see this one? We take this E here is approximately equals to this, is approximately equal to that one. Remember what we have now performed into previous activities. So it means that E0, that E0 is proportional to L0, and what else? And that E, so E1 is equal to L. So which means that the constant of proportionality, as what we have said, is that potential gradient. And then we'll have E0 equals to K, L0, and E1 equals to KL. So what is next? The next point now is now to ask ourselves, what can now be the answer if we take this over E1 equals to L0 over L1. Do you see this? Very simple just to find. It's because we have this E and this E1, we can divide each term, just each side by just the corresponding of the other equation side, and then we find this ratio. So then from this one, you can calculate either E1, that is going out to be equal to E0, then times L1 over L0. So I think that you can determine one of the, just one of the data that was asked when you have a problem. So this is what I came now to explain there, so into that equation, okay? So we have the equation there. So this one, so it is the same as what we have determined, right? So I'm trying now to help you to understand, of course, this comparison of the electromotive forces. If you have followed there, the same as to this one. Then let's have a very, so it means that here what I've said, if the standard electromotive force is known, so suppose that one of that is known, and length L0 and L are known, then E1 can be calculated, right? So we can do that. So we can now find the example here. Read that example, and then find the answer. I'm helping you now to read it out. A potentiometer arrangement arrangement, a cell of electromotive force 1.25 volts, given a balance of point at 35 centimeters length of the wire. If the cell is replaced by another cell, okay, and the balance point shifts to 63 centimeters, what is the electromotive force of the second cell? I'm giving you 1 minute to finish, and then we work this together. Now, as what we have, we can identify the data, right? We start the identification of the data, and then after, we solve. Do you understand? What we have here is a cell number 1, and the balance is at this 35. Okay? So let's do that. So let's work in the same way as what we have here. So let's say that what is here, what is given is this E0, and there is L0 and L1. So this E0, electromotive force, or the standard, is given to be 1.25 volts. So let's say L0 equals to 35. This is 35 centimeters. And what else? What is again given there? The cell is replaced by another. So, and then the balance point shifts to that one. L1 equals to 63 centimeters. Then, as you see, if we are being asked now to find E1, then we can immediately apply the formula. The formula here that we apply is which one? The one that we have there, or the one that we have determined into the previous slide? You remember that? So here we have E0 times L, that is the L1. Here we have L1 over L0. So if we substitute, we find E0 is 1.25 times the 35, because we have the same unit, no reason of converting them into meters. And then we can calculate the answer will be into volts. So this is 0. This is E1 will be equal to, take your calculator and then perform this one with me. So let's go. So what we have there is 1.25, then times 35 over, this is over 63. So then we find, that is, we find 0.69 volts. So we find this one. I hope that, did you find the same answer? Students, I hope you have just worked with me to find the answer by substitution, or by substituting the data into that one, right? So there we have, we need now to perform, let's see. So listen to that one. I'm sorry. Well, there we have 25. No. So this is going now to be L1. L1, it is 63, then over 35. And then when we calculate that, we find 63 over 35 equals to 2.25 volts. So I hope that you have determined the same answers as what we are determining there, right? So then if we look at the answer there that I have prepared for you, we have E1, that is the data, and then we substitute it into the formula. So even if there, I've said it is E2, but still we have the same, the similar formula that we are using. So then let's have a homework. Students, I want you to work on this question as homework, right? So then copy it, and then solve, and I want you to add on more other questions from the different books, right? So what we have here, it is a potentiometer arrangement of a cell of electromotive force 1.5 volt, given a balance point of 30 centimeters length of the wire. If the cell is represented by another cell and the balance point shift is to this one, what is the electromotive force of the cell? So to conclude now, from the objectives that we have said, we said you will now be able to perform the simple circuit experiment by using a potentiometer, right? I think that by having this material, by having this instrument that we are having, you can easily perform that simple circuit into which you have a potentiometer. That is one. So whenever you go back to schools, I know that you will be having the materials. Try to arrange the materials in the same way, and then you carry out this, this demonstration, or you do your demonstration by your own. And number two, we have said now you will now be able to compare the electromotive force. So it means that from these examples and from the circuit diagram into which you have the electromotive force 1, E1, electromotive force E0 here, you could now find that you have, with this potentiometer, you could now find this is the 1 and this is 2, and then you could compare the two. You could compare E1 and E0. So from what we came now to solve here. So then, students, as what I have said, apart from this one question that I'm giving you as a homework, find more other questions from the same book that I've told you. And go to page 123. You have the questions. Thank you for being with me into this lesson. We'll meet again into the other next one. And bye-bye.